and this session is specifically focusing on the cumulative frequency curve. And in today's session, we're going to look particularly at drawing your curve. Now, the cumulative frequency curve in particular is useful for us because we have some applications for it in terms of getting the median for group data, as well as investigating in quartiles, because we'll need these when we look at ranges, interquartile range and semi-interquartile range. Doing your cumulative frequency curve all begins with your cumulative frequency. So we're going to take a look in a little bit at the cumulative frequency because we need to know where our data is coming from before we even start with creating our graph. This is the question. So the table below shows a frequency distribution of the scores of 100 students in an examination. So we're going to take this particular table, we're going to complete the cumulative frequency column, and then we're going to find where the points that we need for our graph come from. So completing our cumulative frequency column in this table, this is what we'll get. Remember, cumulative frequency is simply adding up the previous frequency to our current class intervals frequency. So this is how we got the values of 23, 46, 68, and 89. Now remember, your total frequency and your cumulative frequency should be the same value. So if you do your addition for your cumulative frequencies and you don't get your cumulative frequency summing to the total frequency for your problem, then you need to go double check and make sure that you have added the correct values. For this particular problem, we had a total number of students of 100, and that's why our cumulative frequency is 100. I need to create a cumulative frequency curve. Firstly, when it comes to the cumulative frequency curve, we must know that we use the data that we have where we get the upper class boundaries for each class interval, because this is a value that we're going to use paired with the respective cumulative frequency for that class interval, or at that class interval, I should say. These are the values that you're going to be using. So when you plot your points, you're plotting the upper class boundary with the cumulative frequency at that class interval. So when we list out the ordered pairs for our cumulative frequency curve, pairing up the upper class boundaries with the cumulative frequencies, we get the following list. Our very first point is going to be 25.55. So remember, your upper class boundary is simply the upper class limit plus 0.5. So my first class interval, the upper class limit was 25. My upper class boundary will be 25.5. So I add 25 and 0.5, and this gives me my upper class boundary. So the pairing up of the points now, like I said, we're pairing up the upper class boundary with the cumulative frequency. So 25.5, 5, 30.5, 23, 35.5, 46, 40.5, 68, 45.5, 89, and 50.5, 100. So these are the ordered pairs which I'm going to be using to create my cumulative frequency curve. Now let's talk about the graph area. Remember, scales are important. So in this case, they have indicated to us what scales we should use on the respective axes. They told us that on our x-axis, we're going to use 2 centimeters to represent 5 units. Aside from that, they have indicated they want us to use a broken scale, as well as they want us to have the data starting on the x-axis at 20. How do we know this is our x-axis they're referring to? The horizontal axis. So anytime they ask you about the horizontal axis, you're talking about your x-axis. Now, something to point out, whenever we talk about the x-axis, we're talking about the independent variable. So the independent variable here is basically the scores these students would have gotten. What is dependent is the frequency, because the number of students who got that particular score all depends on if they got the score 12. So that's why our vertical axis or our y-axis will contain our cumulative frequencies. So on our y-axis, they say to use a scale of 2 centimeters to represent 10 students. So we're going to go to our graph page now, and we're going to learn how to set up these axes for this particular graph. Now, in case you didn't understand how to do scaling before, and you want a little refresher on how to do scaling, there is a video provided in the card, which should appear at the top of the screen. There is a video on that where you can actually see how to do your scales from scratch, starting from the 1-to-1 scale, going into the 2-to-1 and 2 to another quantity scale. So you can explore that video and see how to do your scales. In that video also is the discussion of the broken scale. So once you're familiar with doing your scales, you'll be able to start doing your graphs. So let's get started with doing the graph for this particular one. So here we are. This is what our completed cumulative frequency curve will look like. Now, again, some things to point out. Although it doesn't look perfectly S-shaped, you can tell that there is some sort of an S resemblance. It just looks a little bit stretched out. So our S shape forms from the top, come down this way. All right. Now, don't be too alarmed if your curve comes out a little straighter than it should. But this is essentially what your cumulative frequency looks like. And particularly for the scale that we've used on the x-axis, this is what it would result into. Now, one of the things that I really want to point out when you're doing the labeling of your axes, you must at all times write down scales, because if you know what scales you're using, it makes it easier for you to interpret your graph. So we're going to do the entire process of creating this cumulative frequency curve, and you'll see how you set up your scales on your axes properly. Okay, so get your graph paper ready. We're going to get started with doing our graph. And I want you to follow along so that you will get used to doing your cumulative frequency curve through these steps. Now that we have our graph paper and all the right tools, let's begin. So we're going to start off now by looking at our graph paper. Remember, we're going to set up our scales on our axes. We're going to start off with putting our x-axis on the horizontal part of the page, and we're going to set up our y-axis on the vertical part of the page. Let's talk about labeling the axes. My x-axis is recording what data? It's recording the scores. So on my x-axis, I'm going to label this as the scores axis. So I'll come to the end here, and I'm going to write the word scores. And I'm going to write the word scores. Now, let's work on setting up the axes. First of all, let's identify where 0 is going to be. It's pretty obvious our graph will always have the axes intersecting at the origin. So I'm going to label where 0 is at. 0 is at my extreme left corner. This is just my preference because I know I'm only dealing with a positive quadrant graph here. So I start off by putting 0 in the far left corner. Remember, the key things they told us about the scales for our graph. They said that the x-axis is using a broken scale, and it starts at 20, where every 2 centimeters represents 5 units. So let's take it piece by piece. First of all, we know we're dealing with a broken scale. So let's go represent the broken scale. So every time we represent a broken scale, we use this little zigzag to show that the scale is broken. Now, let's continue from there. I'm using the scale where 2 centimeters represent 5 units. First of all, my initial value is 20. So I'm going to put in where 20 is. Now, you could go closer to where the scale is broken at, or you could just use 2 centimeters just because you want to set up, that interval uniformity sort of thing. So I'm going to put 20 here because this is where my scale has to start, all right? So I have my 20 in. Now, remember, 2 centimeters is representing 5 units. So every 2 centimeter interval on my x-axis, I am going to label 5 units. So this means 2 centimeters away from 20 is 25, and then 30, and then 35. You get the idea. So you're going to label this all the way until 50. The reason why we're stopping at 50, our data maximum number of scores is 50. Once we set up our x-axis, all we have to do is set up our y-axis. So I have my x-axis in order. Now let's take a look at how we do our y-axis. So like I said, my y-axis is going to be done along the horizontal part of my page. So I'm going to start off from my origin. Now, what was the scale they mentioned? They said we're using a scale of 2 centimeters to represent 10 units. So in our case, when we go to our y-axis, every 2 centimeters, starting from 0 will represent 10 units. So the y-axis doesn't have a broken scale. That's why we're going to start right after 0. We're going to put 10 at the very first 2 centimeter interval. So this is where 10 is at. Now I'm going to label my entire graph going upward until I get to the highest frequency. So my total cumulative frequency came up to 100. So that is why I'm going to stop off my graph on my y-axis at 100. I do want to highlight when it comes to the y-axis. Yes, in this particular example, they said that on the y-axis, you're going to represent the number of students. Now, number of students in this particular case is indicative of frequency. So on our y-axis, we are representing frequencies. We can write frequency if we like, or we can write number of students. But because of the data we're dealing with, we just might want to write number of students. So let's go. We will label our y-axis as number of students. Now, the next thing I want to do is write my scales in. The reason I want to write in my scales is simply because I want to make that note visually so I remember what was the scale I used and where. So when I'm interpolating and interpreting values on my graph, I know exactly where they're located and I know exactly how to locate them. So let's write in our scales. So on my x-axis, I used a scale of 2 cm representing 5 units. But I also need to highlight the fact that it is a broken scale. So let's write that in. It's a broken scale. Next, my y-axis. On my y-axis, I used a scale of 2 centimeters to represent 10 students or 10 units. Now let's get to plotting the points. We've listed out our ordered pairs. Once we know how to read off points on this graph, plotting those points are going to be pretty simple. So I have my list of ordered pairs. My very, very first point being 25.55. To locate this point, I'm going to go to my x-axis first. So if you can remember how to plot points, then this part of the process of creating a cumulative frequency curve should be a breeze. I'm going to go to my x-axis, locate 25. Now recall, on my x-axis, I'm using a scale of 2 centimeters representing 5 units. Within that 2 centimeter space, I have 10 of these little tiny blocks, really, really tiny. But they're not just for style. The reason they're there are to help us so that we can locate points accurately. So if I wanted to locate 25.5, first of all, I need to know what is the value of one of these tiny blocks. One of these tiny blocks, the value of that would be simply obtained by dividing my total number of units represented in this space by the number of tiny blocks in this space. So I'm representing 5 units in that 2 centimeter space. I'm going to divide 5 units by 10, and that will tell me what is the value of one of those tiny blocks. So 5 divided by 10 gives me 0.5. And that means every one of those tiny blocks represents 0.5. So if I want to look at 25.5, all I need to know is where 25 is, move one tiny block to the right of it, and I'm at 25.5. So 25.5 is along this line here. Now I'm going to locate my actual point because my coordinates are 25.55. So I'm going to locate where 5 is on my y-axis now. So my scale was 2 centimeters representing 10 units, which means that 5 of the tiny blocks on my y-axis represents 5 units there. Plotting the points, I'm just going to find where 25.5 and the line 5 coincide, and that is at this point right here. So I just make a point, make a dot. I can even label the point if I like. I have my first point plotted. Now I'm going to follow that process where I'm going to go through all of my ordered pairs, and I'm going to locate each one of them first on the x-axis, then on the y-axis, and plot those points. Now, if you have difficulty with locating the lines and singling them out easily, use a ruler. A ruler might be able to help you with finding the lines much more easily, especially if your graph paper is not too clear with the minor and the major lines. My last point is 50.5, 100. And once I'm done with plotting that point, all I have to do now is connect my points. Now, let's talk about connecting the points. Remember what I said in the early stages about cumulative frequency? Cumulative frequency curves, and notice the word curve, they don't necessarily look like your typical graphs. They're a little bit S-shaped. And that S does not necessarily have to be that perfect curvy S. But you just need to essentially get the idea as to where the graph curves. So the cumulative frequency has a curve at the bottom starting. Your starting point will be more or less curved. Somewhere here in the middle, it may get a little bit straight. And then coming up to the top, it curves again. So I want you all to remember S-shape, whether it be stretched out and elongated, but S-shape, that's the important thing. So let's draw the graph. So here's what I'm going to do. I'm going to make that connection between the origin and my very first point plotted. That is 25.55 is going to go connect itself to the origin. So I'm going to do a nice little curved piece here because this portion of the graph is going to be curved. So it doesn't necessarily have to be overly perfect. The idea is just to get that curved shape. Now I'm going to connect the rest of points. Now, as you move upward, like I said, it's going to get somewhat straight. So you do your best to connect points. Now you can do them point by point like this if you like. Or if you are a very artistic person, you just might have an easier time with swinging through all the points with one swipe. So as I come up to the top, I want you all to notice this little piece here is going curved. It's not going to go straight. I have seen people with the temptation to use a ruler. Do not use a ruler. Now I'm just going to curve this piece. And that's about it. That's my cumulative frequency curve. So, important things to remember. When doing your cumulative frequency curve, scales are important. Secondly, you must have the cumulative frequencies paired up with the upper class boundaries to get your points to plot. Remember, since your data is going to be your independent variable, you are putting that on your x-axis. So you're using your upper class boundaries as x coordinates and your frequencies, specifically cumulative frequencies, as your y coordinates. Once you plot the points, make a nice, best as possible, S-looking kind of curve, and you have your cumulative frequency curve. Now, like I said, once we have the curve, we have many applications of it. And we use the curve to find the median, to find our quartiles. So in our next video, we're going to talk about quartiles. So you can look out for that video. But I hope this session on doing cumulative frequency curve has been quite useful, quite informative, and you understand better how to do your cumulative frequency curves.